Hello everyone, and welcome back to the channel. Today, we're retaking a deep dive into a topic that's both fascinating and a little bit mind-bending. The story of Manus AI. But here's the twist. We're going to explore its development as if we're looking back from October 2025. This is a speculative journey, a thought experiment based on current trends and expert predictions. So grab your thinking caps and let's explore the future that might be. To understand where Manus AI could be in October 2025, we first have to look at its hypothetical origins. Picture this. In late 2023, the AI landscape was dominated by large language models excelling at text and image generation. However, a quiet revolution was brewing. A consortium of researchers from leading universities and independent labs, let's call them the Aether Initiative, published a groundbreaking paper. Their focus wasn't on making AI bigger, but smarter and more integrated. They proposed a new architecture, codenamed Manus, Latin for hand, symbolizing its goal to give AI the ability to interact with and understand the physical world in a much more direct way. Their core idea was embodied cognition. Instead of just processing text from the internet, the Manus project aimed to build an AI that learned from multisensory input, sight, sound, and, most importantly, virtual touch and proprioception. They developed incredibly sophisticated simulations, digital twins of real-world environments where the AI could manipulate objects, learn physics, and understand cause and effect. The early Manus prototypes weren't great conversationalists. Ask them about poetry, and they'd be lost. But ask them how to assemble a flat-pack chair from a diagram, and they could generate a step-by-step robotic instruction set with 99% accuracy. This was a radical departure from the norm. Throughout 2024, the Manus project hit several key milestones. In March, they demonstrated an AI that could watch a cooking show and then guide a robotic arm to replicate the recipe, adjusting for slight variations in ingredient size and placement. This showcased its adaptability. By summer 2024, they had integrated advanced voice and sentiment analysis. Now, Manus could not only understand the instruction "pass me the wrench," but it could also infer from the user's tone of voice, whether the request was urgent, casual, or frustrated, and adjust its response speed accordingly. This emotional and contextual awareness was a game changer. The real breakthrough, however, came late in 2024. The Aether Initiative announced they had successfully federated the Manus learning process. Instead of one massive central AI, thousands of smaller, specialized Manus nodes were deployed in various industries, from logistics warehouses to virtual surgical suites. Each node learned from its specific environment, and these learnings, stripped of any proprietary or private data, were shared back to the core model. This swarm intelligence approach allowed Manus to learn exponentially faster, an improvement in grasping delicate objects learned by a node in a Japanese electronics factory could be applied to a node assisting in a German laboratory overnight. By early 2025, the first commercial applications of Manus AI began to emerge, not as a single product, but as an operating system for robotics and smart devices. A company specializing in elder care introduced companion robots powered by Manus. These weren't just glorified smart speakers, they could help with daily tasks. Notice if a routine was broken, provide physical assistance, and even detect a fall and call for help. The key was their understanding of the physical space and the context of human action. They didn't just hear "I've fallen," they could see it, understand its implications, and act. In the manufacturing sector, Manus AI created what experts called hyperefficient assembly lines. Instead of robots programmed for one repetitive task, Manus-powered systems could be reconfigured for new products in hours, not weeks. They could perform quality control with superhuman precision, detecting microscopic flaws and even predicting mechanical failures before they happened. This led to a significant boost in productivity and a reduction in waste. With sources like the Future of Manufacturing journal estimating efficiency gains of up to 40% in early adopter factories. This wasn't about replacing human workers, but augmenting them, freeing up people to handle complex problems and creative design, while the AI managed the dangerous, repetitive, and precise physical tasks. Of course, this rapid development wasn't without its challenges. By mid-2025, debates around ethics and governance were front and center. How do you ensure the safety of an AI that controls physical machinery? What happens if a learning node picks up a bad habit? The Aether Initiative, now a larger foundation, worked with international standards organizations to develop a robotic code of conduct. This included principles like the reversibility principle, ensuring any action taken by a Manus-powered robot could be safely and immediately halted or reversed by a human operator, and the sanitized learning protocol, a rigorous process to filter and anonymize all shared data to prevent the spread of errors or malicious inputs. Now, as we stand here in our hypothetical October of 2025, Manus AI is not a sentient being from a sci-fi movie. It is a powerful, specialized tool, a nervous system for the Internet of Things. Its primary interface isn't a chatbot, but a seamless interaction with the world around us. Urban planners are using Manus simulations to model traffic flow and emergency response with unprecedented accuracy. Scientists are using it to automate complex lab experiments, accelerating research in medicine and material science. It's the invisible intelligence that helps a prosthetic hand feel more natural, guides a delivery drone through a complex urban environment, and ensures the smart factory runs smoothly. The story of Manus AI, from a research paper in 2023 to a foundational technology in 2025, is a testament to the power of a different approach. It shows a shift from purely digital intelligence to an embodied intelligence, one that understands and interacts with our physical world. It's a future where AI is not just a brain in a box, but a helpful hand working alongside us to build a safer, more efficient, and more responsive world. The next chapter, leading towards 2030, will surely focus on making this technology more accessible, more secure, and even more integrated into the fabric of our daily lives. Thank you so much for joining me on this speculative journey into the future of AI. What do you think the next big breakthrough will be? Let me know your thoughts in the comments below. If you enjoyed this video, don't forget to hit that like button and subscribe for more deep dives into the technology that's shaping our world. Stay curious, and I'll see you in the next one.